Hello and welcome. Oh my, it's not no longer week 3, we're on week 4 now. Can you believe it? We're on week 4. I'm your host, Dr. B. Welcome to week 4, Accounting 221, Principles of Accounting 2. We made it to almost the halfway mark, right? This is an 8-week course. We're now in week 4. So what happened? Well, it's been a long journey so far. Although, well, long and short, I guess. We're now in week 4. Last week you had your first, I guess, major, semi-major exam, which covered the first 3 weeks of the course. Most of you did very, very well, by the way. Uh, the first 3 weeks went very well for this course, for the most part. Had a few hiccups, in the second week, but we got through it, right? The way that the rest of the course is structured, in this week, we will cover process costing, activity-based costing, and absorption costing. And then in the future weeks, we will discuss cost volume profit analysis, which is a fun topic, by the way. It's next week. Week 6, we'll talk about budgeting. Ooh, budgeting is fun. It's one of my favorites. Week 7, we'll discuss standard and variance costs through decision making. And week 8 is kind of our wrap-up week. We'll discuss a few time value of money concepts. So let's talk about where we were, where we are. In this week, we will talk about process cost, activity-based cost, and variable cost. Last week, we talked about job cost. The reason why I want to talk about job cost shortly is because job cost is somewhat related to process cost. They're very similar topics in nature. In job cost, we talked about the example of a guitar manufacturer. And in job costing, they produce in batches and by the job, right? By the customer order, which is the job. Process cost uses a similar philosophy, but in process cost, we're going to look at continuous manufacturing. And the example we'll give is an ice cream manufacturer because it's continuous. Right? Okay. So this week, what do we have going on in the classroom? We have these 10K statement of stockholders equity discussion. And we will have your homework as it relates to process costing. And we will also have your weekly report out. I'm in the process of providing feedback and grading for the reports from last week, as well as from the discussions. So please bear with me as I work through to provide that grading and feedback. It is very time consuming, as you might imagine. And so my plan is to hopefully have the grading and feedback from last week completed by this Friday. That's the objective. And I'm confident I'll meet that goal, but I just want to let you know that where I was in the process. All of your homework 3 and exam grades have been updated and published to the gradebook. And I'm very happy to report that most of you are doing very, very well. So I appreciate all of you for staying on top of your work and working actively throughout each week. As you know, there's a lot of ground that we cover in this course. Accounting is a very complex subject for most people. And so my objective is to try to make it as digestible as it can be, which is also why we host these optional Zoom sessions. And for those of you who have joined me today, I really do appreciate you joining. As always, if you have a question or a comment, please unmute your microphone and go ahead and ask, or feel free to type it in the chat. And either way is fine. But I appreciate those of you who joined me to be here today. Okay, so let's jump into it. We got a lot of topics to talk about today. I'm going to try to keep it within an hour. You know how that goes. Sometimes we get onto some good conversations. So, okay, so the first thing I want to talk about is process costing. As I said in my opening remarks, we discussed last week job costing. This week, we're talking about process costing. In job costing, we looked at it from the perspective of a customer order comes in and we manufacture the number of units requested in the customer order, and the product moves through the respective departments to be ultimately become a finished good. It starts as raw materials. It goes from raw materials through an acquisition process into work in process. Work in process contains multiple departments. Department A for job costing was the wood cutting. Department B in the process was assembly. Department C was finishing. Department D was packaging. Right. That's the idea of job costing, and that's the organization of companies that use job costing as their system. Process costing is not job based. It's not just a batch of products that are being produced for customers. And process costing, we look at it as manufacturing as being identical and continuous. The example we'll give is on ice cream manufacturing. If you think about ice cream and you go to the grocery store, you notice that ice cream is always there. It's always in the freezer. It's always ready to go. Ice cream is continuous. The ice cream manufacturers continually make ice cream. They use the same process. And it doesn't matter if they have sales or not. They still make it. It's continuous. Another example would be water, folks that make water bottles. Another example would be an oil refinery. It's continuous. Another example would be milk processors, meat processors, vegetable growers, farmers. These are all process manufacturers. Process. It's continuous, nonstop. Doesn't matter if they have customer orders or not. It's always nonstop. And so as the products are manufactured, it goes from department to department to department to department, and all of the product costs add up, just like we talked about when we discussed job manufacturing. It's very similar in that nature. The primary difference between job and process is that job is done by the customer order and process is done continuous. In job order, again, it's in batches. It's based off of the customer orders. And then we fill the customer orders based off the job. Process is continuous. So here are a couple of examples. Pepsi, Coca-Cola, Keurig, and Dr. Pepper, those are all soft drink manufacturers, and they use process manufacturing. It's continuous. They make it regardless of customer orders. Same with Alcoa, who makes aluminum, Intel that makes computer chips, Apple that makes phones, and Hershey that makes chocolate. Those are all continuous. They're process manufacturing companies. Job order companies would include companies like Disney, Nike, Nicholas Design, Tennessee Heritage, DDB Worldwide. These are all job-based. They operate based off of the customer's order, right? And that's the best way to understand the primary difference between process companies and job companies. Of course, they both have a lot of similarities. Process and job order companies both record and summarize product costs. They allocate factory overhead to costs to the products. They both provide useful product information. They classify product costs as direct materials, direct labor, and factory overhead, which, as I said in our very first week, you'll hear a lot about direct materials, direct labor, and factory overhead. Those are the primary costs that go into a product. And they both use a perpetual inventory system for materials, work in process, and finished goods. We talked about the difference between perpetual inventory and periodic inventory. Perpetual, the word perpetual means continuous, right? Continuous. They scan the barcode, it comes out of inventory. They scan the barcode, it goes into inventory, right? Continuous. Continually updates the records. Whereas in the periodic system, they do a physical count. So here's the graphical representation that shows you the differences between job order and process cost systems. In job order, which was what we talked about last week, we have direct materials, direct labor, and factory overhead that are accomplished through departments and through job cost sheets. The job cost sheet represents the customer order. The direct materials, direct labor, and factory overhead fill the job cost sheet, and the job cost sheet is tied to the finished good. In process cost system, we take our raw materials, transfer it to work in process, we add in factory overhead. Then we move it from work in process to another work in process. We add in some more direct labor, direct materials, factory overhead, and then we move it to the finished good. So if you recognize the difference between the organization, between process and job cost systems, you'll have a better understanding of how we allocate costs for each system. Now, as I said, we will be using the ice cream manufacturer as our example for process cost system. You see from that first image on the top, we have our raw materials: milk, cream, sugar. These are things that we use to create ice cream, as you might imagine. So we take our milk, cream, and sugar, we put it into the mixing bowl. That's where it first starts, the work in process. Mixing department. The mixing department mixes the ice cream ingredients together using the materials. Of course, there's going to be some direct labor. Those are the folks actually mixing, right? And there will be factory overhead. The factory overhead includes, as you know, and factory overhead includes things like the depreciation of the mixing bowl. It includes indirect supervisor's salary. It includes things like utilities, rent, that type of thing. And then we collectively add that together. When we move the ice cream from the mixing department to the packaging department, we move all of those costs that we've accumulated over the time it's spent in the mixing department over to packaging. And then in packaging, we're going to add some more direct labor, direct materials, and factory overhead. Direct materials in the packaging department are the boxes. They are the containers that the ice cream goes in. And then, of course, the boxes that the ice cream containers goes in. And, of course, it includes some more rent, supervisor salary, depreciation of packaging equipment, that type of stuff. And then it moves to finished goods. But the key thing to take away from process cost system is that as it moves through work in process, we add additional direct materials, direct labor, factory overhead at each stage of the work in process. The two are different. The job order cost system and the process cost system are, of course, different. In process cost system, as I said earlier, we accumulate the costs as it's in each work in process department. Whereas in the job order cost system, it accumulates based off of each individual job using the job cost sheets. So that's a big difference. In the job order cost system, they also use at the end of the period, we add up the job cost sheets, right? Especially for partially completed jobs. In the process cost system, which is what we're talking about today, the work in process at the end of the period is the sum of the costs remaining in each department. So what do I mean by that? So at the end of the accounting period, so end of the month, there's still going to be ice cream in the mixing bowl. There's still going to be ice cream in the packaging department. There's still going to be some raw materials. There's still going to be something in finished goods. So at the end of the month, or the end of the accounting period, which is typically a month, we add up what's there in each department. Wow, okay, what do I have in my my beginning inventory, my raw materials? What do I have in my mixing department? What do I have in my packaging department? I add up what's in each department instead of on what's each job. So those are the differences. Think about the physical flow when you think about a process manufacturer, the physical flow. I want you to think about like a conveyor belt or conveyor belt. That's the best way to think about it. Or moving from one pallet from one location to another. Think about the physical flow. You have your raw materials at the beginning of the conveyor belt. We take it out of raw materials and put it on the conveyor belt and moves to the mixing department. The raw materials go into this big mixing bowl. Okay. And that's what the mixing department is. And you got a few people that are overseeing the machines, and they're working the churn and all that good stuff. And they're making the ice cream. Then once it finishes the process, it goes back on the conveyor belt, and it goes into the containers, right? From the big metal thing, and it goes into the containers. It evenly measures it all, right? And it moves its way down the containers move their way down the conveyor belt to the packaging department. They put it all into boxes. And then they move the boxes into the freezer, which is where the finished goods are. So as you're thinking about process, think about the physical flow. In the process cost system, the costs of units transferred out of each processing department are determined along with the cost of any partially completed units remaining in the department. In other words, just as we discussed in job costing, we have what we call whole units and partial units. A whole unit is a whole gallon of ice cream. That's a completed unit, okay? A whole unit. And then we also have partial units. This is units that have not yet been completed. Partial units would be, I partially filled this gallon of ice cream. I have material still in the mixing bowl. I have material still in raw materials. These are what we call partial units. And to figure out how much each partial unit is, you first need to know what is the cost of a whole unit. And then once you know what the cost of a whole unit is, you can divide it based off of its parts, right? And that's how we get partially completed units. We'll talk more about that. So the cost of production report is what summarizes all of these costs. the cost of production report summarizes it based off of the units the department is accountable for and the disposition of those units. Or disposition means moving it out of that department, or disposition also means the movement of those units out of that department. Disposition. It's a fun word. It means a lot of different things. The product costs incurred by the department and the allocation of those costs completed, which are transferred out of and partially completed units. In other words, the department is responsible for both whole units and partially completed units. So, what are the steps to preparing a cost of production report? Remember, in managerial accounting, we talk a lot about internal reports that are used by management to make decisions. That's why we call it managerial accounting. The cost of production report is a managerial accounting report. You'll never see a cost of production report in a 10K. It's just not going to exist because that's internal data, right? So cost of production report, what are the steps to creating one? Number one, we determine the units to be assigned costs. Units to be assigned costs means I have a whole unit that has not yet been assigned the direct labor, direct materials, factory overhead to that respective unit. When you hear me say the word unit, think of an individual product. That's a unit. Like a gallon of ice cream. That's an individual unit. So we have units that have not yet been assigned costs. So number one, we determine the units that need to be assigned costs. Step two, we compute equivalent units of production. So as I said earlier, we figure out what the cost is of a full unit. We then need to figure out what are the individual costs of that unit. This is called the equivalent units of production. Step three, we determine the cost per equivalent unit. That's basically like saying, I now know how much a fourth of a gallon of ice cream costs. Right? So think of a full gallon of ice cream. Let's say it costs $1. A fourth of a gallon of ice cream might cost 25 cents. Right? So that's the individual cost of an equivalent unit. Think of it like you're breaking down the costs. That's the best way to think about this process. And the fourth step is to allocate costs to be transferred out and partially completed units. Yeah, fun stuff, right? The cost of production report, as we prepare it, we make assumptions of cost flow. You earlier learned in Accounting 220, you learned about the costs of inventory, right? How to value inventory. You learned about first in, first out, last in, first out, and average cost for inventory. And as you might expect, since we're talking about things like ice cream, okay, we likely assume that the manufacturer uses first in, first out. The reason being is because of the physical flow of the inventory. So, especially things like ice cream, we know that it's perishable. So, the first in, first out method is what we would apply. It's very common for processing companies to use first in, first out. For example, an oil refinery is going to produce several million barrels of oil a day or gasoline a day. And they're going to ship that first gallon out first, or the first barrel out first. So it's the same concept. It's the physical flow, right? Physical flow. So we assume that we use first in, first out for computing the cost of our inventory. So here's an example. As I said, the example we're using throughout this concept is going to be an ice cream manufacturer. Here's an example. So for the month of July, this is our cost of production report for the month of July. We started the month with 5,000 gallons of inventory, direct materials, right? Direct materials inventory. We completed 70% of that original 5,000 gallons in the month of July. What does that mean? Well, we took 70% of the 5,000 gallons out of direct materials inventory and moved it into work in process. That's what that means. And as we move materials out of raw materials to work in process, there's cost associated with that, right? We have direct labor, the direct materials, and factory overhead. Conversion costs are the direct labor and the factory overhead that accumulate for the production. So my conversion cost for the 5,000 gallons is 70%, based off of what was produced, right? So 5,000, that's 1,000. So the remainder, 30%, right? 1,225. So our total inventory in process starting on July 1 was 6,225. The direct materials cost for the month of July, think purchases, right? Or think purchases. We purchased another 60,000 gallons for the month of July. Direct materials cost for the month of July, 60,000 gallons, was 66,000. Direct labor cost for the month of July. These are my employees that are working in the mixing department and the packaging department. My direct labor for those people for the month of July was 10,000. My factory overhead applied for the month of July was $7,275, giving me a total cost of production for the month of July of 90,000. Okay, how I got 90,000, 66 plus 10 plus 7,275 plus 6,225, and so forth and so on, right? So once I figured out my total cost of production to be accounted for, we then look at what was transferred out. So gallons transferred to the packaging department in the month of July from our mixing department was 62,000 gallons. Okay. Our inventory in process at the end of the month was 3,000 gallons. So basically our ending inventory, right, in process was 3,000 gallons at 25% conversion cost. Remember, the conversion costs mean that we're adding the direct labor and our overhead for those gallons, right? So for the 3,000 gallons. By preparing the cost of production report, the cost of gallons are transferred to the packaging department in July.
Wait, Professor, can you go over that last one? That went in one ear and out the other, and I was watching you hand in hand. Can you take that from the top one more time, please?
Yeah, my pleasure, Brittany. Absolutely. So this is the cost of production report for the mixing department. We started the month of July with 5,000 gallons. It's our beginning balance inventory. Direct materials cost was 5,000 gallons at $5,000, so $1 per gallon. Our conversion cost for the 5,000 gallons is $1,225. Why is it $1,225? You might be asking. Well, if we completed 70%, of course, the difference is going to be 30%. That's how we got to 1,225, 30% of 5,000. The total inventory in process, meaning in the mixing department at the beginning of the month of July was 6,225. The direct materials cost for the month of July was for 60,000 gallons was $66,000. So that's a little over $1 per gallon. It's probably like $1.25, if that. It's like $1.07. The month of July, we basically think of think of it this way. It's like purchasing 60,000 gallons that we're going to process during the month of July. Of course, we didn't process the whole 60,000 though. Well, we almost did. We ended up processing 57,000 by the end of July because it says that we were left over with 3,000 gallons. We incurred $10,000 of direct labor for the month of July for the mixing department, and we also incurred $7,275 of factory overhead for the month of July for the mixing department. And all that great stuff together to get $90,000 for the production costs for the month of July for the mixing department. At the end of the month, for the month, we transferred out 62,000 gallons of ice cream to the packaging department. So if you look at it, we started with 5,000, we purchased 60, we finished 62,000 gallons, right? For this department. If we finished 62,000, we started with 5, brought in another 60. That tells us we were left with 3,000 gallons at the end of the month that we did not yet process. And the conversion costs for that 3,000 gallons was 25%. Brittany, does it make a little bit more sense? I mean, it's difficult to, without actually reading through the concepts first, but.
Okay, that's why, because I usually watch your thing first, and then I go back and do the reading. That's why. Okay.
We'll talk more about it. But yeah, it comes a little bit more challenging without actually reading through the concepts.
Yeah, I like to listen to you, and then I go back and read it, so I know kind of like what I'm looking for, and then I go back and read. Okay, I'll try a different technique. Okay, makes sense.
All right, cool. It's just a matter of kind of identifying, what is the concept of conversion cost, because the primary difference between process cost and job cost is the process, right? So instead of doing jobs or batches, we're doing it continuously. So as we continuously move it from one department to another within the work in process, there are conversion costs associated with that movement. And so that's what these conversion costs are. It's adding that additional direct labor and overhead. And so after we've prepared the cost of production report, we transfer those costs to the packaging department And we basically do the same thing for the packaging department. The idea of the report is that it's prepared for each process department. And our example is one is the mixing department. The second is the packaging department. Report summarizes and quantifies the data according to cost, the units for which each department is accountable for, and the disposition of those units. The production costs incurred by each department and the allocation of those costs of transferred out or partially completed units. So, in other words, if you look back at the production report, for the month of July, the mixing department was responsible for 62,000 gallons, and 70% at the beginning of the month, 25% at the end of the month. Think of the conversion cost as the partially completed units. So we need to make journal entries to represent all this stuff in our accounting system. That's how we make the transactions, right? That's how we make it obvious where things are. I want you to think about it from the physical flow. Okay, we start with raw materials. It goes to the mixing department, then it goes to the packaging department, then it becomes a finished good after that. The mixing department and the packaging department are both work in process departments. Okay. So let's work through a couple of examples of transactions that we would make in our journal entries. The first one is we purchased raw materials. You debit your materials or raw materials, and you credit accounts payable. Debit your materials, and you credit accounts payable. In this case, it was $88,000 worth of milk, cream, sugar, and packaging materials, and some indirect materials. That could be like packing peanuts or things like that, right? The next transaction, the mixing department requisitioned milk, cream, and sugar from the raw materials of 66,000. Remember, the word requisitioned. It means I put a requisition form, a request form, if you will, into the raw materials area to transfer the raw materials into work in process, in this case, the mixing department. The value of that is 66,000, okay? This is the total amount from the original July data. Packaging materials were 8,000, and then we have some indirect stuff. So here's the transaction. We debit work in process mixing department, 66,000. We debit work in process packaging department, 8,000. We debit factory overhead mixing department, 4,125. We debit factory overhead packaging department, 3,000. And then we credit our materials, 81,125. Questions? Does it make sense? Are we getting there? Brittany, does this make a little bit more sense?
Yeah, no, the journal entries make sense to me because I see it and it makes sense. It's all the other stuff that this I could see, yeah.
Okay, great. So Brittany, the way to think about it is that these journal entries that we're making is what builds or creates the cost of production report.
I can tolerate that. That makes sense.
All right, cool. Okay, a couple more transactions. We incur direct labor in the mixing department and the packaging department, as you might expect. You debit work in process mixing, 10,500. Debit work in process packaging, 12,000. Credit wages payable, 22,500. Just remember, that's the direct labor part. And then, of course, we got some more factory overhead. Transaction D, fourth transaction. We recognize depreciation of our equipment in the mixing and packaging departments. We debit factory overhead for mixing department, 3,350. We debit factory overhead packaging department, $1,000. We credit, that shouldn't be wages payable. I apologize. That is not wages payable. That should be depreciation. That should be accumulated depreciation. I don't know why it says wages payable. 4,350. I just noticed that. That's not right. Sorry about that. A couple more transactions. Applied factory overhead. Applied factory overhead, as you know, is like this is the factory overhead that gets applied to each respective department as we accrue it. Okay, and the factory overhead includes things like supervisors' salaries, utilities, depreciation, so forth and so on. Debit work in process mixing department, 7,275. Debit work in process packaging, 3,500. Credit factory overhead mixing, 7,275. And credit factory overhead for packaging, 3,500. It's very similar to what you learned before with respect to journal entries, making adjustments. Yeah. The primary difference here is that we're working with two different departments. So that's why you see, it's like, oh, Dr. B, it's the same thing. No, it's not. The difference here is that we're working with each individual department. So that's why we make these types of entries, work in process mixing, work in process packaging, because mixing is one department, packaging another department. We treat them individually, although it's collective. That's why we call it process manufacturing. Well, one of the reasons. Last transaction. We transfer costs of $86,475 from the mixing department to the packaging department. So here we are, end of the month. We transferred from the mixing to the packaging. We debit work in process packaging, credit work in process mixing. We're just moving it from one work in process area to another.
Wait. Quick question. And it's not about the numbers. The numbers make sense. That's just following the physical flow, right? So in the beginning, we said physical flow. That's just going from A to B.
Exactly right. That's the whole. You got it. What you just said is the exact concept of process costing. It's following the physical flow. So if you think about the physical flow as it moves through the process, raw materials to the mixing department, to the packaging department, and then to finished goods eventually. If you follow the physical flow, all you're doing is you're adding the cost as it goes through the process. Yeah. And then you take that total cost from the one department and you shift it to the next one.
Can I ask you a question in that physical flow? Okay, it's starting to make a little sense. As we're doing that, is it safe to say we're allocating the overhead at that point?
That's correct.
Okay.
So that's exactly right, Brittany. So what you do is you at the end of the month, or that's when we make the journal entries. But you're right. as it's going through the process, we're adding in the direct materials and we're adding in the factory overhead. And then you basically add all that together at the end, and you transfer it to the next department. Exactly right. Okay, a few more. I thought I was almost done. Okay, we're going to transfer goods. Transfer goods, finished goods, right? Out of the packaging department and into finished goods. You debit finished goods, ice cream. So that's the name of the finished good. And then you credit work in process packaging. But you see here, so if you look at it from the beginning of our entries, we started with 88,000 in raw materials. We brought in 66. We added in our overhead, got us to 81. Then we transferred the addition. Then we got some additional labor, right? And additional factory overhead got us to 86. 86 from the mixing went into packaging. And then, of course, while it was in packaging, we accrued more direct materials, direct labor, factory overhead. Got it up to 106. 106 went out of packaging and into finished goods. So again, more of the physical flow. So debit your finished goods, credit work in process packaging. And then we sold it. Then you sell it, right? I don't know why you'd only sell for $1,000 revenue, but so cost of goods, when you sell it, debit cost of goods, 107, credit your raw materials. I'm sorry, your finished goods. What am I talking about? You debit your cost of goods sold and you credit your finished goods when you sell it. Yeah. Well, of course, you're going to make the sales transaction as well at the same time. Yeah. Hopefully we sold it for more than it costs. Okay. That is process manufacturing. Process. Any questions on process before we move into activity-based costing, which is one of my favorite topics, by the way? Good? Okay. I'm sure you'll have questions as you read through the material as well. So as you have questions, please feel free to ask. You could post your questions in the Ask the Professor forum, or questions about homework or whatever's easiest. Or you could even email them to me. It's fine. Okay, activity-based costing. The idea, okay, so we're shifting gears, not entirely, but mostly, okay? We're still talking about cost, but we're not talking about process. We're not talking about job. We're talking about activities. When we talk about activity-based costing, we're talking about the activities that are involved in the manufacturing process. For example, assembly is an activity. Assembly is an activity. What am I trying to say? There's another couple of activities I want to talk about. Assembly is an activity. Inspections, meaning quality control inspections, that's an activity. What's another one? Trying to think here. There's a ton of different activities. Inspections, that's an activity. Assembly as an activity. Design, like redesigning a product or making modifications to a design. Those are that's engineering a design. That's an activity. And there's a lot more. We'll talk about them. The idea behind activity-based costing is we look at costing through the lens of activities in the business. So real quick, let's talk about product costing again. As you know, product costs include direct materials, direct labor, and factory overhead. Within direct materials, direct labor, and factory overhead, we have what we call direct cost and indirect costs. Direct costs are your direct materials and your direct labor. Your indirect costs are costs that cannot be easily traced. That is your factory overhead. In addition to direct costs and indirect costs, we also have conversion costs. And conversion costs are something we just talked about when we talked about process costing. Conversion costs include direct labor and factory overhead. Those are conversion costs. The reason why they're conversion costs is because you have both direct labor and factory overhead in each department in the process, right? And that those costs get converted to the finished cost, the finished product cost. Let's talk about the allocation of factory overhead costs. When we talk about activity-based costing, we need to first talk about two other methods of costing. There are three methods of costing that companies utilize. Well, they'll use one of these three. They're not going to use all three. A company will use one of three methods for allocating factory overhead costs. The first one is called the single plant-wide rate method. That's a mouthful. Single plant-wide rate method. The single plant-wide rate method takes all of the factory overhead costs and simply divides it by the expected output. Or the overhead budget. It takes the overhead budget divided by the expected output, and that gets you your single plant-wide rate. We'll talk about it. Just telling you what it is. Okay. And of course, that includes direct materials, direct labor, factory overhead for the total cost. But we're just talking about the factory overhead. Okay. The second method is called the multiple production department rate method. Another mouthful. In the multiple production department rate method, the company has more than one department. And each department will have its own factory overhead rate. And the third method, which is what we're going to focus on today, is called the activity-based costing method to apply factory overhead. And in the activity-based costing method, each activity has its own factory overhead rate. We're going to break down each of these, okay? So the three most commonly used methods for applying factory overhead are the single plant-wide factory overhead method, the multiple production department method, and the activity-based costing method. Managers need to be able to calculate all three methods to determine which method is the most appropriate for identifying the most accurate cost for overhead per unit. Now, the example we're going to use for this concept is a company named Ruiz Company that manufactures both snowmobiles and riding lawnmowers. Okay, that's our example. And we're going to talk about the single plant-wide method, the multiple department method, and the activity-based method using this example. Our company, Ruiz, manufactures both riding lawnmowers and snowmobiles. Okay, so that's the company. Using the single plant-wide method, the factory overhead rates costs are allocated to products using one rate. So in other words, I use the same rate of overhead for both snowmobiles and riding lawnmowers. Doesn't matter. Okay. We know they're two totally different products. We know that they're going to have two totally different costs. And the level of input, meaning direct materials, direct labor, are going to be different for both snowmobiles and riding lawnmowers. But for simplicity, companies will use a single plant-wide rate method for overhead. Okay, so let's assume that our company, who manufactures both snowmobiles and riding lawnmowers, has a total overhead budget of $1.6 million. And we have budgeted direct labor hours of 20,000 hours. 20,000 hours. I am going to the company allocates 10,000 labor hours for snowmobiles and 10,000 labor hours for riding lawnmowers. The company plans to produce 1,000 units of snowmobiles and 1,000 units of riding lawnmowers for the year. It takes 10 hours of labor to produce one unit. 10 hours of labor to produce one unit. So it takes 10 hours to make one snowmobile. It takes 10 hours to make one riding lawnmower. So using the single plant-wide rate, which is the most simplest one ever, we take the total budgeted factory overhead, in this case 1.6 million, divided by the total budgeted plant-wide allocation base. Okay, here's what that means. The allocation base is the unit of measure for the operating activity. In our case, for Ruiz Company, it's labor hours. Because remember, I budgeted labor hours for the year. So in this formula, we would take 1.6 million on the top line divided by 20,000 hours on the bottom line. And that will give us our single plant-wide rate method, our single plant-wide factory overhead rate for each hour. Yep, for each hour. So in our example, 1.6 million divided by 20,000 hours is $80 of overhead per hour. Now remember, it takes 10 hours to produce one unit. So what we would do is we would take 10 hours times 80, which is 800. $800 would be the overhead cost per unit in using the single plant-wide method. So the way it works is you take your $80 per hour of overhead times the number of hours per unit equals the overhead cost per unit. In this case, it's $800 for both snowmobiles and riding lawnmowers. That's per unit. Yep. So just imagine if we're creating 1,000 snowmobiles and 1,000 riding lawnmowers, you take 1,000 times 800. So it adds up over time. I'll show you that here in a little bit. And this is just a nice graphical representation of how it works. So $1.6 million is our budget for factory overhead. You divide that by the budget number of hours, which is 20,000. 1.6 million divided by 20,000 is $80 per hour. $80 per hour times the number of hours it takes to create each unit, in this case 10 hours, gets us to $800 per unit of overhead cost. Again, it's a very simple method of allocating overhead. Very, very simple. That's the advantage of using single plant-wide method. Very easy to use. It's inexpensive to implement. You don't need to be a rocket scientist to be able to figure it out. Very, very easy. But there's some challenges with this method. It assumes that the consumption of factory overhead is the same across different products. I can already tell you the difference between making a snowmobile and a riding lawnmower is totally different. Okay. It takes a different number of hours in fabrication and assembly for each unit. So in our company, Ruiz company, we have two departments. We have the fabrication department and the assembly department. In the fabrication department, we are fabricating the metal. Okay, we're making them. We're shaping the metal to encase for the snowmobiles and the riding lawnmowers. Metal fabrication for a riding lawnmower is going to be a lot different than it will be for a snowmobile, right? Because obviously, there's different parts. It takes a different number of hours. And the same can be said for assembly. So that's one negative for using plant-wide method is it doesn't take that into consideration. Another negative for using single plant-wide method is it does not apply to companies that manufacture different products. It's very difficult to use this for this particular company because this particular company manufactures two totally different products. They're not in the same category, right? If it was in the same category, then yeah, I'd probably use that method, but not for this company. Okay, so that's single plant-wide method. Does it make sense? Is it straightforward? Hopefully, yes? Great, thank you, Brittany. Okay, let's talk about the multiple production department for factory overhead rate method. Oh man, such a long name. Just say multiple production department method. Okay. When production departments are different significantly in the manufacturing process, the factory overhead costs are normally incurred differently in each department. For example, if our company has a metal fabrication department and an assembly department, those are clearly very different departments. They do very different things. They're both work in process, but they do different things. It's like in the ice cream example, a mixing department and a packaging department, totally different things. So the rate should be different. Yeah. So in this case, the factory overhead costs may be more accurately allocated using the multiple production department method. This method uses different rates for each production department to allocate factory overhead costs and to its products. This is very different than the single plant-wide method because single plant-wide method doesn't take differences into consideration. It just takes the whole amount for the whole company, right? 1.6 million divided by the budgeted hours, right? To get one rate. This is totally different. This is more accurate because we are allocating based off of two different departments. So let's compare the two side by side. Single plant-wide rate. Again, you take the total budgeted overhead divided by the total budgeted activity base, in this case, labor hours, to get you to your plant-wide rate. In our example, 1.6 million divided by 20,000, you get $80 per hour. In the multiple production rate, we apply a factory overhead rate for each department, and apply that to the product. So let's talk about it. Our company has two departments. we have a fabrication department that's metal fabrication, and we cut and shape metal. And we also have an assembly department that manually assembles the pieces together to create the final product. Our factory overhead budget for the year, as we said, was $1.6 million. The company has decided to divide the $1.6 million into the two departments, not evenly. The reason why it's not even is because the company understands that there is more that goes into fabrication than assembly. So here's the breakdown the company decided on. We got $1,030,000 allocated overhead to the fabrication department, and $570,000 allocated to the assembly department. Remember, the total budget's $1.6 million. So regardless of how the company allocates it, it still needs to equal $1.6 million. So let's look at it. Remember that we had 20,000 of direct labor hours budgeted for the year, 10,000 to create snowmobiles, 10,000 to create riding lawnmowers. So in multiple departments, we simply take those total labor hours and divide it by each department. In this case, 10,000 hours have been allocated to fabrication and 10,000 hours have been allocated to assembly. So it's a relatively simple computation. It's the same as what we did before. The only difference is it's by department, not for the whole company. So we take our budget amount divided by our budget amount for the department. So budget for fabrication was $1,030,000 divided by 10,000 hours that have been budgeted for the fabrication department equals $103 of direct labor hours of overhead for each unit that comes out of the fabrication department. And for assembly, we budgeted $570,000 divided by the 10,000 labor hours allocated for the assembly department gets you to $57 per direct labor hour for assembly. Now, as I said earlier, there is a different number of hours for fabrication and assembly based off of each respective unit. The snowmobile requires 8 hours in fabrication and 2 hours in assembly, whereas the riding lawnmower only requires 2 hours in fabrication and 8 hours of assembly. Remember that it takes a total of 10 labor hours to create one snowmobile and 10 labor hours to create one riding lawnmower. So you can see where we're going with this. We have $103 per direct labor hour for fabrication. So what do? We take $103 per hour, multiply that by 8 hours for each snowmobile and 2 hours for each riding lawnmower. $57 per hour was allocated from assembly of overhead. So $57 will be 2 hours for snowmobiles and 8 hours for riding lawnmowers. And then you add them all together. Best way to do it is through a spreadsheet, of course. We accountants love spreadsheets, don't we? Okay, so here's how it works. As we said, to create one snowmobile, it takes 8 hours in fabrication and 2 hours of assembly. We said that it takes $103 for each direct labor hour for fabrication and $57 per hour for each hour in assembly. So you take your 8 times 103 gets you to 824. 2 times 57 gets you 114. You add the two together, and for each snowmobile, the overhead is $938. For the riding lawnmowers, fabrication is 2 hours, and the assembly is 8 hours. Fabrication, 2 hours times $103 per direct labor hour of overhead for fabrication gets you to $206. For assembly, 8 hours times the $57 for assembly overhead gets you to $456. You add the two together, each riding lawnmower factory overhead per lawnmower is $662. You all see how that works? Does it make sense?
Pretty good.
Great, thank you. Okay. So that's multiple department. Okay. It's very similar to the single plant-wide rate. The only difference is we apply that same concept to each individual department. Now, you'll notice the difference here. So, using the single plant-wide method, we had $800 per unit. It was unbiased as to what unit it was. It didn't matter whether it was a snowmobile or a riding lawnmower. It was $800 of overhead per unit. Then we worked through the multiple department method. Snowmobiles $938, riding lawnmower $662, leaving us a difference of $138 for each unit. Now, here's the interesting thing. Single plant-wide rate said $800 for snowmobiles, $800 for riding lawnmowers. Snowmobiles $938, riding lawnmowers $662 for the multiple department overhead. That leaves us a distortion cost of $138 more for snowmobiles and $138 less for riding lawnmowers. That is why using the multiple department method is more accurate for a business that has different products. Now let's compare those two to the third method, which is of course, going to be the most accurate, activity-based costing. Activity-based costing looks at overhead based off of their activities. Activities, as you know, are types of work or actions that are involved in the manufacturing process. An activity could be welding. An activity could be inspections, quality control inspections. An activity could be assemblies or setups, I should say. A setup, think of an assembly line, okay? An assembly line consists of multiple steps in assembly, right? Or multiple activities in assembly. Think of like a auto manufacturer. Well, you start out with making the frame of the car. Then you got another activity of installing the engine. Then you have another activity of installing the doors, another activity of installing the tires, and so forth and so on, right? And then it makes it to the end of the assembly line. Then there's more activities after that. There's inspections, quality control inspections. Now, when you do a quality control inspection, you don't just look at it and say, oh, yeah, it looks good. No, it doesn't work that way. Quality control inspection means we disassemble it and then reassemble it. That is a quality control inspection. The idea behind it is to look for defects. When it comes to setups, the word setup means we are setting up the assembly line. Okay, we are recalibrating the machines. We are oiling the machines. We're getting them ready for use for the day, right? That's called a setup. And then of course there's more activities that are involved, but these are just some examples of activities. We'll talk more about it. Under the activity-based costing method, factory overhead costs are initially budgeted for each activity. Of course, each activity has a budget. It's just like how in the last method we talked about the multiple department method. Each department had its own budget. In activity-based costing, each activity has its own budget. We call these budgets for activities activity cost pools. Yeah, right. It's a fun one. And what is the basis? we use for each activity. Machine usage, machine hours, inspections, moving, production setups, engineering activities. These are all concepts of activities, right? Or activity costs, I should say. So in contrast, multiple production department, the factory costs are accounted for in the production departments. So here's a nice graphical representation. We talked about in the multiple production department, each department had its own budget, and each department was assigned its own rate, its own overhead rate. Think of activity-based costing as a further breakdown at a more granular level of assigning rates. Each activity has its own budget, and each activity will have its own respective overhead rate. So here we go. So as you know, we have a fabrication for our company, Ruiz. We have a fabrication department and an assembly department. Within the fabrication and assembly departments, we have setups, quality control inspections, engineering changes, the actual fabrication, and the actual assembly, right? Those are the activities. Fabrication is an activity, just so happens to be within the fabrication department, but it's also an activity. Assembly, that's an activity within the assembly department, but it's still an activity. And then, of course, within each of those departments, you have setups, quality control inspections, and engineering changes. Fabrication, we budgeted $530,000. Assemblies, we budgeted $70,000. For core activities, that's a total budget of $600,000. And then we also have what we call sub-activities or related activities. Setups, for the related activities, we budgeted $1 million. Setups, we budgeted $480,000. Quality control inspections, we budgeted $312,000. And engineering changes, we budgeted $280,000. Remember, setups is when we're setting up an assembly line. We're recalibrating the machines. We're getting everything in spec. Quality control inspections, these are disassembly and reassembly of finished goods to validate that the finished good is of quality, right? Of quality. And then engineering changes. These are changes that companies make periodically to finished goods to improve them. An example would be you went from iPhone 10 to iPhone 11. Okay. In that process, we implemented engineering changes to improve the iPhone. So altogether, our annual budget is $1.6 million for the overhead cost. How do we calculate the rate for each activity? Budget activity costs were assigned to products using the factory overhead rate for each activity. We call these activity rates. For each activity, to find each activity rate, we take the budget for the activity cost and we divide by the total activity base usage. I know, it sounds funny, right? Activity base usage. And the activity base is the used because it's related to an activity. So an example would be, we'll say for setups. For setups, we have a budget for the activity of $480,000, and we're going to complete 100 setups. So you would take $480,000 divided by 100 setups. 100 setups is the activity base usage, right? So let's look at it for each activity. So we expect to create 1,000 snowmobiles and 1,000 riding lawnmowers for the year. Our company has estimated that we will do 100 setups for snowmobiles and 20 setups for riding lawnmowers throughout the year. We also estimate that we will complete 100 quality control inspections for snowmobiles and 4 quality control inspections for riding lawnmowers throughout the year. We also estimate that we will implement 12 engineering change orders for snowmobiles and 4 engineering change orders for riding lawnmowers throughout the year. Oh, I'm sorry. Sometimes my mouse gets a little crazy. Okay, so remember the hours. We have 10,000 hours dedicated for snowmobiles, 10,000 hours dedicated for riding lawnmowers. And as we discussed earlier, fabrication for snowmobiles is 8 hours, assembly 2 hours. For riding lawnmowers, fabrication 2 hours, riding and assembly 8 hours. We expect to produce 1,000 units of snowmobiles and 1,000 units of riding lawnmowers for the year. So 8 times 1,000, 8,000. 2 times 1,000, 2,000. That gets you to 10,000. So forth and so on, right? Okay. Let's look at the activity-based usage for both the snowmobiles and riding lawnmowers. As we said earlier, snowmobiles fabrication will be 8,000. Fabrication for riding lawnmowers is 2. Assembly for snowmobiles is 2,000. Riding lawnmowers is 8,000. We said that there will be 100 setups for snowmobiles and 20 setups for riding lawnmowers. You add the two together to get to 120 setups. Quality control inspections. We expect to do 100 quality control inspections for snowmobiles and 4 for riding lawnmowers. It's 104 inspections total. Engineering change orders. We expect to do engineering change orders for the snowmobile 12 times and 4 times for the riding lawnmower. That's 16 change orders total. How do we figure out the activity rate for each activity? You take the budget for each activity cost divided by its activity-based usage. Fabrication, 530,000 divided by 10,000 hours, it's $53 per direct labor hour. For assembly, 70,000 divided by 10,000 labor hours, that's $7 for assembly, per labor hour for assembly. Then you have your setups. Budget was $480,000 for the year, divided by 120 setups. That's $4,000 per setup. Quality control inspections, $312,000 allocated, budgeted for that, divided by 104 inspections. That's $3,000 per inspection. And engineering changes, $280,000 was budgeted, 16 engineering changes total. That's $13,000 per engineering change order. Does that make sense? Any clarity that needs to be for this so far? We're almost done. It's taking a little bit of time because this is a very important topic. Okay. Now, of course, we have to allocate the cost to each product, right? Now that we know what the activity rate is for each activity, we need to take that activity rate and multiply that to the activity-based usage. Overhead, to find the activity overhead to be allocated. Overhead costs for each activity rate are allocated to the product using this formula. Take the activity-based usage times the activity rate. The estimated total factory overhead for a product, this is a sum of the product's individual activity allocations, in other words. I add up all of the activity rates for each unit to get the overhead cost per unit. The factory overhead cost per unit is determined by taking the total factory overhead cost divided by the total units of estimated production. Now, let's look at it from, of course, the spreadsheet. Love spreadsheets. We take our total activity costs for each product type. For snowmobiles, fabrications, 424,000. How do we get there? 8,000 direct labor hours times $53 per direct labor hour of activity. That's 424,000. Assemblies, 14,000. How do we get there? Well, we already know that we allocate 2,000 of direct labor hours and it's $7 per hour. So that's 14,000. Setups. We said we were going to do 100 setups for snowmobiles. So that's $4,000 per setup. That's 400,000. Quality control inspections. We're doing 100 for snowmobiles at $3,000 per inspection. That's 300,000. Engineering change orders. We did 12 at $13,000 a piece. That's 156,000, giving us a total factory overhead cost of $1,294,000 for snowmobiles. We said that we were going to produce 1,000 snowmobiles for the year. So you take your total factory overhead for snowmobiles, divide that by the total estimated units that we expect to produce of snowmobiles to get our total factory overhead cost per unit. So $1,294,000 divided by 1,000 equals $1,294 of overhead per snowmobile. What about riding lawnmowers? Same process. Fabrication, total of 106,000. Assembly, 56,000. Setups, 80,000. Quality control, 12,000. Engineering change orders, 52,000, giving us a total factory overhead cost for riding lawnmowers of 306,000. I expect to produce 1,000 of them. 306,000 divided by 1,000 is $306 of factory overhead per riding lawnmower. And that, my friends, is how activity-based product cost works. And this is just a nice graphical representation of that. Now, as I said earlier, it's important for managers to be able to compare all three methods to determine which method is the best for allocating factory overhead per unit for the company. We see in our example for Ruiz, $800 per unit for single plant-wide rate for both products, which really is not very accurate. Okay. Multiple production department rates. For snowmobiles, $938, riding lawnmower $662. It's a difference of $138 between the multiple production rate and the single plant-wide rate. Now, here's the thing. If we were to select that one, right? It's close, right? It's better than the single plant-wide rate because these are different products, but it's still not as accurate as it can be. Then we get to the activity-based costing method, and we see that snowmobiles was $1,294 and riding lawnmowers was $306, which is a significant difference from the multiple production department rate and a very significant difference from the single plant-wide rate. So we know that activity-based costing is the most accurate when it comes to allocating overhead per unit for our company. Now, if you add up, going down, if you add up, you realize it's all the same, right? But the concept behind understanding activity-based costing is to realize how accurate we can be when it comes to allocating factory overhead on a granular level. Okay, so that's activity-based costing. Any questions so far before we jump into absorption? Absorption is very straightforward, very simple. So this part will not take us long. I'm sorry. I'm sure we're going over time, but it's important that we get through it. Are we good so far? You all still with me?
We're here.
Okay. Very cool. Thank you, Melinda. All right, great. Let's keep rocking and rolling. Okay, absorption costing. This is required under GAAP for financial statements. Absorption costing. Think of the word absorption. Absorption. What does it mean to absorb? It means, think of a sponge. Okay. What does it mean? What does a sponge do? You put the sponge on the liquid absorbs into the sponge. Okay. It's the same concept, except we're talking about costs. Direct labor, direct materials, fixed and variable factory overhead costs. These costs get absorbed into the cost of goods manufactured. And you know that because you know that the cost of a product is direct materials, direct labor, factory overhead. So since you know that, all of those individual costs are absorbed to create the cost of the finished good. So in financial statements, these costs are included in cost of goods sold once we sell them on the income statement and are found on the balance sheet as finished goods inventory. But you all know that. You guys are so smart. Come on. Okay, so this is your standard income statement. And as you can see, we have absorption costs. Sales minus cost of goods sold equals gross profit minus selling administrative expenses equals operating income. Your absorption costs are found in cost of goods sold, direct materials, direct labor, factory overhead, but not all factory overhead. Okay, not all. Only fixed and variable costs of factory overhead are found in cost of goods sold. There is another part of factory overhead, which we talked about, I believe, last week, called selling and administrative expenses. Selling and administrative expenses are related to the cost of goods sold because we need to sell the product, right? So, and how do we do that? We have salespeople, so sales salaries, and you have administrative expenses, cost of billing, advertising, all that type of stuff, right? Things that are related to selling administrative. So that's why we see that selling administrative expenses is listed separately than cost of goods sold. So I mentioned earlier that factory overhead consists of fixed and variable costs. Fixed and variable costs, very important that you understand fixed and variable costs. Fixed costs are fixed. They don't change over time. They don't change with the level of output. Fixed costs would be things like rent. Rent don't change. Rent's still the same. Okay, that's not going to change. It changes regardless of the level of output. Variable costing, on the other hand, changes with the level of output. If I make 1 unit versus 50 units, my variable cost changes because I'm using more electricity, because I'm using more labor, because I'm using more indirect materials, so forth and so on, right? So the idea of variable costing is the cost changes as we consume more direct materials, direct labor, and variable factory overhead. Remember, variable changes with the level of output. Under variable costing, fixed factory costs are not a part of the cost of goods sold. So they're expensed out. Fixed factory overhead costs are treated as period expenses. Under absorption costing, which we just discussed, we absorb direct materials, direct labor, variable factory overhead, and fixed factory overhead. We absorb it. Okay. That's basically all of your costs associated with manufacturing are absorbed into the total product cost. The difference is in variable costing, direct materials, direct labor, variable factory overhead are part of the cost of goods sold. Fixed factory overhead, like rent, like supervisor salaries, other things, indirect stuff, are expensed out. They're expensed out. So we know that the total cost of goods sold, cost of goods manufactured, are going to be higher under absorption costing than they will be under variable costing. And what happens when we have higher cost of goods sold and lower expenses is we know that the net income is going to be different. Or the operating income is going to be different. So under variable costing, the report looks like this. We have sales minus variable cost of goods sold equals manufacturing margin minus variable selling and administrative expenses equals contribution margin. Somebody asked earlier, I forget who, I don't think it was any of you, asked how to compute the contribution margin, but this is the way how you would do it. If your company, if your 10K company that you selected, if you're looking to find contribution margin, this is how you would do it if your company is a manufacturing company. Contribution margin minus your fixed costs or your total fixed costs. Fixed costs include fixed manufacturing costs and fixed selling and administrative expenses equals total fixed cost. Contribution margin minus total fixed costs equals operating income. Okay. The reason why I show you the difference between absorption costing and variable costing is because some companies will opt for one or the other. Ones that opt for variable costing, we typically see a lower cost of goods manufactured. And because of that, we have an increased margin. Yeah. Manufacturing margin is the excess of sales over variable cost of goods sold. Manufacturing margin is sales minus variable cost of goods sold. Variable cost of goods sold include direct materials, direct labor, and variable factory overhead. Contribution margin is the excess of manufacturing margin over variable selling and administrative expenses. Contribution margin equals, this is the form of contribution margin, manufacturing margin minus variable selling and administrative expenses. And the difference between fixed costs and the contribution margin is operating income. This is the basics of variable costing. I forgot I included this slide. This is an example of a company that manufactures 15,000 units, sold at $50 per unit. It's not this example is probably not the best one. I probably shouldn't have included it, but the total variable manufacturing costs were $375. How we got there is the cost per unit is $25 times the number of units produced, $375. Manufacturing fixed costs are said to be $10 per unit. 10 times number of units produced is 150,000, giving us a total manufacturing cost of $525,000. Selling administrative expenses are $5 per unit times 15,000 is 75,000. Total fixed selling administrative expenses is said to be 50,000, giving us a total selling administrative expenses of 125,000. So what you would do is you would take your sales minus your total cost manufacturing, 525,000, minus your selling administrative expenses, 125,000 to get to your operating income. So it's an okay example. It's really not the best one. It's what I could do in short order, right? And this is an example of what the variable costing income statement would look like. sales minus variable cost of goods sold equals gross manufacturing margin minus variable selling administrative expenses equals contribution margin minus your fixed costs equals operating income. So nice and easy. Basically, another way of thinking about the variable costing is you're breaking out variable versus fixed. And there we are. That's the end. Yay. Oh my goodness, I'm 42 minutes over. I am so sorry about that. But we got through it. I made sure to stop on the most important parts that I want you to really understand. I know that not everyone in this class is going on to be an accounting major, and you're probably going to hire your own accountant at some point, and you might be an overseer or manager. But the idea behind you learning these concepts is that if you're ever faced with a situation in your workplace where you need to understand each individual cost of a product, you have a great understanding of how to apply the factory overhead. So that's why I touched a lot on activity-based costing and the differences between plant-based and multiple department-based, things like that. So any questions at all about this week or about the course, anything? You're all good. I know it's a lot of information to consume, especially in the first day of the week, but any questions?
After the reading, check your inbox. After I get my couple of, that's the best I can tell you because I took the notes, but until I read it and then I look at it again, I'll probably have like several in your inbox or on the, in
I
your
got
inbox.
you. No problem, Brittany. And then, as you're reading, you're going to see how what we just talked about tonight is going to click in. It'll probably make a little bit more sense.
I think you've given me more insight because I was trying to make sure that I caught these where you break it down, but I was thinking that would make my reading easier, but I see it's not. I need to actually do the reading first and then I can solve the PowerPoint. I think that's
the
going to
idea.
change it.
Yeah, sometimes it's best to kind of read before attending the session, so that way you'll probably have a few more questions.
I think that's what I'm going to do going forward.
Yeah, that's usually the best way to approach it. But
okay,
but my thing is, I like to host these sessions on the first week of the course because it provides you with some more insight, so that way as you go forward, it just makes things easier.
Yeah, I'm definitely going to do that next week. I'll try to do my reading earlier and then do that next.
Yeah, and then come to class with your questions because it helps everyone, and I'm sure people like Ryan or Justice or Melinda have similar questions, and so it's good that you have those questions.
Okay, definitely we'll do that next week. Definitely doing that.
Sounds great. Cool. Thank you so much.
All right, thank you for the heads up.
Yeah, my pleasure. Any other comments, questions, concerns before we adjourn? Adjourn, as they say. You good? Okay, well, thank you so much for attending. I really appreciate your time. I know you're all very busy. I respect what you do. And if you ever need any help, you just drop me a line. You got my phone number. You got my email. And of course, you can always drop a line in the, in the classroom in the discussions. And I'll be happy to respond there as well. So thank you all so much. Have a wonderful, wonderful evening. Wash your hands, be safe, do all the right things. And I will see you again next time, which is in about a week from today.
Thank you.
Thank you, Melinda. Appreciate you coming. Thank you so much. Thank you,
Thank
Brittany.
you.
Thank you, Justice. Thank you, Ryan.
Thank you.
I really appreciate all of you being here. Thank you so much. Take care, y'all. Bye-bye.
Bye-bye.